4.5, the ready and the set. We're going to exclude the go. So if you don't see any problems from the go, it's because we're not doing them. I hope you're having a great day, and we'll dive right into it. Our topic is interpreting phrases that imply an inequality. We're rewriting the given word sentence as a math sentence. Using each math sentence, we have the greater than, less than or equal to, and greater than or equal to symbol that we'll use. We're using X in place of the number. Sounds like a pretty good agenda, right? Okay, in this example, I'm thinking of a number that is greater than X. So sometimes it's helpful to think about what numbers would work here. So in this case, number greater than 13, 14 could have worked. 13.5 could have worked. Or 13 1/10 could have worked. But the idea here is that it has to be greater than 13. So 13 and a little bit. So that's why X is opening up and then 13. And I'm thinking of a number that is at least 13. So at the least 13. So that implies at least means it could be equal to. It could be higher, but it has to be equal to potentially. So this would be X greater than or equal to 13. And I'll skip around. I'll do some other ones. Thinking of a number that does not exceed 13. So not exceeding, meaning it's going to be less than, but it could also be equal to. It's less than or equal to there. Let's keep this going. Thinking of a number that is no more than 13. This is problem 5, so no more than 13. Well, yeah, I'll leave 5 for you, actually. I'll keep it fun. Thinking of a number that is fewer than 13. That's an interesting one. Fewer than, not less than. What do you think about that? Well, you would have wanted to equal 13. The idea here is that as long as it's less than 13, it's all good. Hope that makes sense for you. What else do we have? Let's jump to 8. Thinking of a number that is less than 13. Simple. X is less than 13. So notice that we can use fewer than and less than, kind of the same approach or same idea. I'll take a look at 9. I'm thinking of a number that is not under 13. So we're thinking of a number that's greater than 13. But could it be 13? Is 13 under 13? No, it's not. So we could have it equal to. Makes sense there. The set, right? And solve inequalities from a context. Take a moment, pause the video, read through what this is saying, and we'll touch base in a second. So you should have read through the problem. To take sweepstakes for the largest pumpkin crop at the Riversdale County Fair, the average weight of Ethan's 2 pumpkins must be greater than 875 pounds. There are 2 pumpkins, and we're talking about the average. One of his pumpkins weighs 903 pounds. What is the least amount of pounds the second pumpkin could weigh in order for Ethan to win the prize? Take a moment, think about how this could be put together. So you should have been saying something to the effect of how, if you're taking an average, you know that you have 2 pumpkins here. And I'll kind of illustrate this first before I dive into it. So you have the 1 pumpkin, and you know that if you add that with the other pumpkin, and notice we have 2 of them, so we have 2 versions of the pumpkin, we know that this must be greater than 875 pounds. So this has to be greater than 875. And so we know one of the pumpkins. So if we just took one of these and plugged in 903, we could have 903. Because again, we know the weight of one of them. We don't know the weight of this other one though. So we could put in a variable there. So we'll call this X, and this is the weight of the second pumpkin. Okay, sound good. And we know we're taking the average of this, so we want to divide by the number of pumpkins, which is 2. We know this has to be greater than 875. So there we go. We made an inequality that showed what was going on. Hope that helps. Part B has us describing in words the quantities that would work in this situation. Well, we could just solve this. I mean, why not? We're here. So I'm going to rewrite what we have, which is 903 plus x when divided by 2 should be greater than 875. What do you think the first step is that we could do here? Hopefully you're saying multiply by 2. You can do that here, do that here. 2's cancel. This gets us what? 1750. So 903 plus x equals 1600 and then 150, so 1750. Keep going to solve for x. Subtract 903 from both sides. This should say that x is going to be equal to 847. Sorry, 67. I think. Well, let me double check this. I was right the first time. It's 847. There we go. Write our answer in both interval and set notation. Remember that set notation. Well, what do you think that looks like? Well, interval, we know that, and again, this is all greater than, x is greater than. We know that if it's the interval, we know that we're talking about where it's going to work using parentheses or brackets. So this is starting at 847. This could go all the way up to infinity. Can't be equal to it though. And then if we're talking about set notation, we could say with this inequality, x just has to be greater than 847. We kind of said that already, but set notation looks like this. And the other two problems, I think just have you reading through what story is happening and then going from there. I hope that helps. If you have any questions, holler, let me know. Thanks for watching.